Hi everybody, Mrs. Pesic here.
And Miss Bella here.
And we are working on section 5.2, multiplying and dividing rational expressions.
In this lesson, we're going to simplify rational expressions and multiply and divide rational expressions. Remember, a rational expression is a quotient or ratio of two polynomials.
Okay, so we have some examples here. X squared minus 9 over x plus 3, 5 over x squared minus 4, 2x plus 3 over x minus 7. These are all examples of rational expressions.
Okay, what we're going to be doing in here to start off is simplifying just like we did with fractions. So in this example, we started off here with 14 over 21. And in order to simplify this, we want to figure out what are the factors of 14. So 7 times 2, and 21 was 7 times 3. Looking at those factors, you notice they both had a factor of 7. So if there's one in the numerator and one in the denominator, I can reduce, and that becomes 2/3.
Okay, so now we're going to do the same type of thing with simplifying rational expressions. So here we could say, think of this as 10 over 6 times x to the 8th over x to the 4th, and we can reduce the 10 over 6. 2 goes into 6 3 times, 2 goes into 10 5 times. And here, remember, when we're dividing two numbers with the same base, we subtract their exponents. So this is really going to be x to the 8 minus 4, which is x to the 4th. So our final answer is going to be 5x to the 4th over 3.
And another way I like to think about that too is if you look at your x's, you had 8 in the top and 4 in the bottom. So if you take away 4 from the bottom, that leaves you with 4 left in the top, if you want to kind of cancel it out that way as well. Okay, so your first must do for your notes is to simplify 16x to the 10th divided by 8x to the 2nd.
Okay, so go ahead and put that in your notes, and when you are done with that, restart the video.
Okay, so for our next example, we have the rational function x squared plus x minus 2 divided by x squared plus 2x minus 3. Now, like we did on the previous page, we first have to figure out what are the factors or what goes into each of those expressions.
Okay, so the best thing to do is to factor here. So if we're going to factor out x squared plus x minus 2, you might want to recall the product sum technique. The product here would be 1 times a negative 2, which is a negative 2, and the sum would be the middle coefficient here, which is 1. So what two numbers multiply together to give you a product of negative 2 and add up to 1? We would say a 2 and a negative 1. So we can take out the x term and rewrite it with these two. So 2x and a minus 1x. We've got x squared plus 2x minus 1x minus 2. Factor by grouping. We get x times x plus 2 minus 1 times x plus 2. We've got the same thing here, so we can rewrite this as x plus 2 times x minus 1. And if you could just see that without doing the product sum, that's fine also. So far we have x plus 2 times x minus 1 in the numerator.
Okay, so for the denominator, again, I'm going to walk you through product sum one more time on this one. So we're going to factor x squared plus 2x minus 3. If we do product sum in this case, again, my product is a times c, or negative 3. My sum is my b value, or positive 2. So two numbers that multiply to negative 3 but add to 2 in this case would give me a positive 3 times a negative 1. Again, I'm going to replace the center with that, so each of these will get an x. So I will have x squared plus 3x minus 1x minus 3. The first two have an x in common, so I'm left over with x plus 3. The second two, I'll factor out a negative 1, so again in my parentheses will be x plus 3. Again, remember, I want to make sure my parentheses match to know that I'm on the right track. So that becomes x plus 3 times the quantity x minus 1. So I'll add that up to my problem up here.
Okay, so now we notice that we have an x minus 1 as a factor in both of these, so we can divide out x minus 1 in both, and we can rewrite this as x plus 2 over x plus 3, and that will be our final answer for this problem.
Okay, so to finish this up, you have your must-do number 2. So you need to simplify 3x plus 4 divided by the quantity 3x squared plus x minus 4. Again, just a hint to get you started. For this bottom here, you're going to want to use product sum method, and you're going to want to factor that and then see if any of your factors cancel and you can reduce.
Okay, so go ahead and pause this to do this notes must do, and when you're done, restart the video.
Okay, we need to recall that when we have something kind of off by a sign, we can switch that around with a -1. So if we had the quantity of x minus 3, okay, oh no, x minus 3, that's really the same as factoring out a -1. So I could factor out a -1 and I would be left with -x plus 3, or that's the same as -1 times the quantity of 3 minus x.
Okay, yeah, because if we have -1 times a negative x, that gives us a positive x, and -1 times positive 3 gives us the -3. This might come in handy with our next example.
Okay, so again, in this problem we want to simplify, so I'm going to start off by simplifying the numerator. The first thing I always want to look at is there something in common? So 4x minus x squared, both of those terms have an x in common. So if I factor out x, I would be left with x times 4 minus x.
Okay, and in the denominator, we can factor that. We could use product sum. If we do product sum, product would be -8, sum would be -2, and we would end up with x here, and a 4 here, and a 2 here, and a minus and a plus. Does that look right, Ms. Bella?
That does look good. Now, if I want to reduce, I want to notice that this factor on top, 4 minus x, is very similar to this this factor on the bottom, x minus 4.
So close, yet so far.
Using that little recall we did up there, how could we make it so that I have the same factor to cancel on top and bottom? Well, I'm going to remember, using what we just talked about, that this factor right here, 4 minus x, is the same as a -1 times the quantity x minus 4. So I'm going to do a rewrite there.
Okay, and after we rewrite that, we can, since we now have the same thing, x minus 4, both top and bottom, we can divide out the x minus 4 here with the x minus 4 here. And we'll be left with x times a -1, which is a -x, over x plus 2. And that will be our final answer. Miss Bella, can we divide out this x with this x?
No, you cannot. You could only do that if it was a factor, so it had to be multiplied together. So if I had something maybe like x over x times x plus 3, since it's multiplied, in that case, you could factor out an x. But in this one, since it's what's plus 2, you cannot.
Okay, so let's clear that out so no one has that in their notes. Oops. Clear those out of there. Okay, so our final answer should be -x over x plus 2. All right, so your turn. You get to try one last notes must do, and then we do have a few more examples for you. So for this one, you are going to simplify 10 minus 2x over x minus 5. So factor what you can, and you might need to, somewhere along the line, factor out a -1.
Okay, so pause this until you're done, and then you can resume after you finish that must do. Okay, so when we are multiplying rational expressions, we have some steps here that can help us every time we do this. So step 1, we are going to factor all numerators and denominators completely. So either product sum, take out what's in common, break each of those down. Step 2, we'll divide out common factors of the numerator and denominator, which means, again, if the factor's on top and bottom, we can cancel one out in each place. Number 3, multiply the numerators together, and then multiply the denominators together. And then step 4, we'll make sure the numerator and denominator have no common factors other than 1. So we want to make sure we didn't miss anything kind of in those steps.
Okay, so let's take a look at this example. We are multiplying two fractions together, and so we're going to try and reduce first. So we might think of this first one as, might split this up into 3 over 2 times x to the 5th over x cubed, and y to the 3rd over y to the 7th. And remember, if you are dividing two numbers with the same base, like we are right here, we would subtract the exponents. So we would get x to the 5 minus 3. That would give us x squared. So we've got 3 halves times x squared, and then 3 minus 7 would be a -4. So we could actually rewrite this as 3x squared over 2 y to the 4th, because remember, if it's y to the -4th in the numerator, it would become y to the 4th in the denominator.
let's simplify the second part here. So again, we can think of this as 10 over 9 times x to the third over x to the second times y to the fourth over y to the fifth. Again, doing that same process, 10 over 9, that does not reduce, so that's going to stay. X to the third over x to the second, thinking about 3 minus 2 becomes x to the first. And for my y's, y to the fourth minus y to the fifth would give me y to the negative 1. So this is really 10x to the first, if you want to put that there, over 9y to the first. Again, this negative y has to go to the denominator.
Okay, and so at this point we are ready to multiply the two numerators together. So if we multiply 3x squared times the 10x to the first, that gives us a 30x to the third, because if we're multiplying two numbers with the same base, we add their exponents. And then in the denominator, we get 18y to the fifth, because the 4 plus 1 gives us 5.
Now my final step is I want to make sure that everything is reduced as possible. So again, I could think about this as 30 over 18 times x to the third times 1 over y to the fifth, or y to the negative fifth there. 30 over 18 is going to reduce. They both have a factor of 3 in common, or 6 in common. So this is going to become 5 thirds. There's no x's to cancel out there, so x to the third, and my y will stay in the denominator. So altogether, 5x to the third over 3y to the fifth.
Okay, so now we've just practiced some multiplying. Let's recall that if we're going to divide by a fraction, you multiply by the reciprocal. So if you were going to if you're going to divide 1/2 by 3/4, you could rewrite that as 1/2 times the reciprocal of 3/4, which is 4 thirds, and that would give us 4 over 6, which we could reduce to 2 over 3. So let's try that principle with an example with rational expressions.
So we are going to divide x to the fourth minus 9x squared over x squared minus 4x plus 3, that rational expression, by the second rational expression. So the first thing we want to do is to change this division sign into a multiplication. And the way that I'll do that is I'll bring down my original as is. Okay, so that one does not flip.
So the first fraction stays the way it was?
And then the second one is the one that I'll need to take the reciprocal of. So this will become x squared minus 16 divided by x to the fourth plus 2x to the third minus 8x squared. We're going to need some room here, so maybe we scoot this whole thing down. We can factor that a little bit.
Okay, so now the fun begins. We start factoring. We can factor out x to the fourth minus 9x squared. We could write that as x squared times x squared minus 9. I'm factoring out x to the fourth from both of these. And then in the denominator of that first fraction, again, you could do product sum on that. And that's going to factor into, let's see, I'm going to have an x here, a 3 here, a 1 here, minus for both. Is that right, Miss Bella?
That looks good.
Okay.
Okay, for the next part here, x squared minus 16. Again, I remember 16 was a perfect square. X squared is a perfect square, and it is a difference. So this will become x minus 4, x plus 4. In the denominator, I noticed that each of these terms had an x squared in common. So I would take that out first. My leftover would be x squared plus 2x minus 8. And I noticed that that's still a quadratic, so I would have to use product sum for this part. Again, if you use product sum with your product of negative 8, sum of 2, this should be x and x. Looks like we're going to have a 4 and a 2. And this would be a positive, and that would be a negative. So that would break down into that. Does that look good?
I think that looks good. And now we can factor one more thing before we go on. We notice again a difference of two perfect squares right here. So we could really factor x squared minus 9 into x plus 3 times x minus 3. So we're going to rewrite that x squared minus 9 like that. And now if we start dividing things out, we can say x minus 3 here divides x minus 3 here divides out with this x minus 3. The x plus 4 here divides out with this x plus 4. This x squared here can divide out with this x squared. Anything in the numerator can divide out with anything in the denominator if they're all factors, if they're all being multiplied. So we are going to be left with x plus 3 times x minus 4 over x minus 1 times x minus 2.
And we don't necessarily need to multiply that out. You just want to do one final check and make sure that none of those are common factors, which we have plus 3 minus 4 minus 1 minus 2. So none of those can go any further, and they cannot factor anymore. Okay.
Okay, so on this example, now we're solving an equation. We're trying to solve x squared minus 25 over x minus 5 equals 14. So we could cross multiply, but it's probably easier to just try and factor. X squared minus 25 is a difference of two perfect squares. So that will factor into x minus 5 over x minus 5 times x plus 5. And we're dividing by x minus 5. And we want to know when that's equal to 14. But the x minus 5 here can divide out with the x minus 5 here. So we get x plus 5 equals 14. Subtract 5 and we get x equaling 9. And we should probably check that.
Right, you always want to make sure that you check your solution here to make sure it satisfies the original. So if x is 9, I'm going to have 9 squared minus 25 divided by 9 minus 5. I want to know, is that equal to 14? Well, 9 squared is 81, so I have 81 minus 25 over 4, or 81 minus 25 is going to give me a 56 over 4, which is equal to 14, so it equals the original, so this is a solution. X equals 9 works for my original equation.
All right, looks good. Let's try one last problem. This one is same type of deal. We're solving. Check your solution on this also. And so if we factor out the x squared plus 3x minus 10 using product sum, we'll end up with an x here and here. We'll end up with a 5 and a 2 here and here. We need a plus there and a minus there. And we're going to divide by x minus 2 equals 7. And then we can divide out the x minus 2 here with this x minus 2. We get x plus 5 equals 7. Subtract 5 from both sides, we get x equals 2. So 2 is our solution.
Well, let's check and make sure it works, and then we can say it's our solution if it satisfies the original. So again, x equals 2, I'll plug that into the beginning. So 2 squared plus 3 times 2 minus 10 divided by 2 minus 2. I want to know, is that equal to 7? In the numerator, I'll have 2 squared is 4, plus 3 times 2 is 6 minus 10, all over 0, or 10 minus 10 over 0, which is 0 over 0.
That's not equal to 7, Ms. Bell.
That's not equal to 7. And remember, anytime you have a 0 on the bottom, you know, we kind of have a problem here. You can never divide by 0. So that means that x equals 2 is not a solution, and this problem has no solutions for the given equation.
All right, and so that completes our notes for this section. So I hope you took good notes, got all your notes must-dos completed, and we'll see you next time.
All right, thanks for watching.